So Virtual.PYXIS is placed in 3 places, basically in US, here in Chicago, the place where I am, in Germany, in Hanover, and in Brazil, in partnership with a company, VirtualCAE. We are a partner of ANSYS, so a software development partner, and the idea here is the topology optimization. The idea today is to talk about the new feature of SpaceClaim version 16, which is the faces feature. I will show you a little bit more how to prepare a model from topology optimization results using STL5. But at first, what's exactly the topology optimization we are talking today? Topology optimization is the idea you get some new design from an extended design. An example like this chair. So you start from an extended black box, and after that you get your final results, which is the best design under this load and restrictions. Virtual.PYXIS, it's a software integrated to the ANSYS environment. So we use ANSYS solver during optimization. We do not use any other finite element solver for the optimization cycles. And it's suitable for linear static frequency and nonlinear analysis, also including geometry, material or friction contact. We have been using modern filtering techniques for to getting a better result, especially when you are talking about frequency results. And manufacturing constraints also something we can use very much for different kind of manufacturing applications. And also it's a unique solution for compliant mechanism, which is a flexible mechanism involving a lot of nonlinear constraints, and also for model pre-stress and optimization of multiphysics analysis, which is the main idea of using ANSYS multiphysics. So here is a short overview about the design workflow of the software. So for the process we can use ANSYS Workbench, for example. Here you see the software. Also later you show how to prepare inside the Workbench. And the partner for the development of this ACT is SSS in Brazil. Solver we also have, besides ANSYS, also Abacus for interface with the solution, and post-processing with, for example, ANSYS Workbench, or even ParaView, which is a open source code for post-processing. So what we have here for the first part of the presentation, the workshop. So I have a real model. This is engine support, as you can see here, with some components. So there is the engine block here, which is just a part of it. It's more generic, and but the idea is to have the engine block is to have the bolt pretension load, which is we also can have some stiffness here. The support itself is this part, this one in green now, and also here you can see, as the chair example below, we have some kind of extended design to give the software the opportunity to get the best design for the optimization. We have also some screws here represented later by both loads, which you give also some stress around this region. So here we have, just to show you some contacts. The first one is in between the engine block and the support. Here you are using frictional contacts, and the friction coefficient is 0.15. bond and contact for screws and support, and bond and contact between this, for example, this screw and the engine block. Also, there's situation also for this contact, for example, it could be like a frictional, but here you use it bonded, just a general case, just for simplification. So here you can see an overview also of the mesh, and can be also could be also a finer mesh, but here is just to show you more generically how does it work. There's some mesh controls. For example, here we are emphasize the element size of 5 millimeters for this support. So when you are working with polymerization, it's nice to have this kind of control because you give ANSYS the opportunity to have more or less a uniform element size for the surface also inside, which gives you a good result for the polymerization result. Here's talk about the load steps. We have here 6 load steps, and the force for these load steps is applied around this hole, as you can see here, the green region, sorry, the red region. And the 6 steps is, those are real forces, for example, in Y, X, and Z direction, which is, for example, conditions of the engine during the application. So, for example, you are having a lot of different conditions for this, and you can for different directions you have to account these forces for the optimization. And also here we have some both pretension loads. Here, as you can see, and the load is 36 kilonewtons for everyone. So after that, you see the final result of your model. For example, in displacement, the maximum is the load step number 2. And also for the equivalent stress, some variation, also including the pretension both load as a main constraint for this model. But remember that the both pretension, you apply the load from the first load step, and after that you lock it. So from the step 2, 4, and 6, which are the maximum force, the load pretension effect will be there. So after this, you now start the optimization with Virtual.PYXIS. So here you just dropping down the analysis of this optimization model. So just some time to start the optimization window. So now, as you are, for example, ANSYS Workbench user, you are very familiar with these 3 as we have seen before. And now you see Virtual.PYXIS as also in the project tree. And here you can prepare some settings. For example, in this case, I want to control, for example, the minimum member size of my model, which in this case we used to have, for example, 2 times the element size as a minimum member size. For example, here we are using 5 millimeters, so we use 10 millimeters as element size. And also, just to remember you, if you have any question during this WebEx, just write a chat so I can see. You can send also for everyone. And we try to answer you at the end of this presentation. So after that, for example, here you also can use some additional settings, for example, to generate the STL file at the end of the optimization cycles. So you get, for example, in this case, the minimal interactions is number, you can control here. In this case, you have 30 interactions, at maximum 6 interactions. So this is some recommendation for the a general case, but you also can edit these interactions, for example, 40 or even 20 interactions. So it depends on the every model, but in general, 30 to 60 interactions, it works fine. And also you can, for example, here generate for the last interaction of your model. In this case, for example, if it's 30, to generate this STL file, which will be used for the SpaceClaim, these new feature phases that we are doing today. So also, if you have a possibility to run ANSYS in parallel processing, here you can enable this and, for example, use 4 processors for the ANSYS HPC that you have, for example, to run faster every ANSYS interaction. So here I will choose this support as the main design or design entity. And after that, now, for example, I can use a constraint of the volume of my structure. Here, for example, I want to control my optimization model to have, for example, 35% of the initial model, which means this is the last value that I have at the end, so 35% of the initial value. And also again for this support. So now I have to create some load case combination, and the question is why? Because, for example, as I showed you before, here we have a load conditions, and the loads are applied in different steps. Not, for example, like this time 2, you have just Y force. So there's nothing here, nothing here. So in this case, as you see different load, forces in different load cases, you have to create this load case combination, because the optimization has to see this, for example, 2, 4, and 6 load step as something that you can take care during the optimization. If you have forces applied at the same time, there's no meaning to create this. So just the optimizer, you take a look about, for example, every step and try to maximize the stiffness for everything. So after that, for example, the last step is you can control or you can set up your objective. In this case, we want to optimize the maximal stiffness of my model. Here, for example, I say maximal stiffness is the same way to say minimal compliance. So again, for this geometry, I'm calling the combination of load steps I created before. And also here from the constraint part, you can also have some manufacturing constraints for most of the applications you have, and casting, open direction, other stuff like that. So here I will not create this as a general model, and also you recommend this for optimization. First you have a look always your final design, and after that you try to understand this final design and try to apply the best manufacturing constraint. But here you can control this situation without any problem. So after that, here everything is fine, so you can start your optimization. Now we call ANSYS for the solver, as you can see here. Of course, here it will take some time, and I don't want to go to the end of this optimization And I just want to show you what I can do after I get the final result. This is example takes, for example, in between 1 to 2 hours result. So after that, for example, here I just close this window and also this one. I will open this final condition of my model. Here. So for example, here you see the results of the optimization. It's just loading the results. Take just some seconds. So here, for example, I just filter the solution. So here is the final result of the situation of the support. So you can have more or less a look if I change the view from the initial to the last design, different views, for example, like this, or lateral views. And you see here that there was a big change in between the first and the last design. Also, you see red regions of material around the main member of the structure and around the bolt load, both regions. And you see more or less the shape where you can control, for example, in the next run, the manufacturer. In this case, for example, you could also have an opening for this direction and Y, for example. Okay, so after this, if you go to the folder or the director of your analysis, you see for the last iteration the STL file, which is the DS31. So with this STL file, you can go to this new version of this new feature of the SpaceClaim, and you can use this to very easy to prepare a new solid model of your topology optimization result, or even for other situation you have an STL file. So here, a bad thing when you don't have a feature like, for example, this separate. You see here everything is together. So also you have the new design of the support, but also you have the block and also the screws, which is sometimes difficult for a new design, as you have to we have more parts for your model. So the first steps, I'll tell you something about 4 steps to prepare the final solid model. The first step is separate all models. So you just click on the separate here, which is the way to disconnect all the parts. So as you can see here, everything now is separated. You have just to click for these parts which are not useful. And now, very easy, you have your support model just it. So, and for example, also you have a yellow indication here, which is something is wrong about your mesh. So next step here is you have some fix for this mesh, which is this auto fix button. So you just press it, you select your model, and after that now it's okay. There's no more yellow indication, which is your model is fixed for the understanding of SpaceClaim. You also can have some check of your mesh here to see what's wrong or not with your every triangle element. Intersections is not our case here. If you have some intersection problem or even holes in your model, not hole like this is part of the optimization, but holes inside the connection of your mesh. There's also problem like this. And also fix some sharps. For example, sometimes you have you have some some parts of your model with very something like this, but it's very local. You can go and fix this problem. Other stuff that I will not go very deep today, but you also can merge or subtract or intersect every part of your mesh. For example, when you have two parts, try to connect them together. Before I end this step of the SpaceClaim, I just want to show you there is a very nice here button called Smooth. And you see, for example, the mesh is like this now. And then when you press the Smooth button and you select your part and you confirm this operation, so after that you see that it is very smoothed now. So it's a kind of remesh of your model, which is sometimes very nice for your model. And also another nice operation you have here is so-called regularize your mesh. For example, here you can select some triangles, for example, these parts. So now you see the mesh is not very nice. And after you just confirm, you have a better uniform mesh for what you have selected. So again, is another nice option you can use here. But for this example, I want to show you a very also nice feature which is the reducing your model. For example, here I want to reduce 95% of my triangles. And here I select the model. It's just taking some seconds to get this result, which is SpaceClaim try to reduce your the number of triangles of your model, and also join some triangles which are very close to each other without any variation angle, for example. Which this operation is nice because when you go back to the ANSYS SpaceClaim, sometimes when you have a lot of faces, it's a bit difficult, for example, sometimes to generate the mesh. So here you have a very clean mesh. For example, the inclination of the surface, they are not very different from the beginning, but you have a very little number of triangles. And after that, for example, here, there's also a yellow indication. You can also fix your mesh again. Nice, one more time. So the last step is convert this as a solid, merging the faces. So now you have a solid model for your mesh. And the idea here is sometimes when you are working with topology optimization, for example, you want to see if this final model is good, for example, for stress or even for frequency analysis. So the idea here is to very quick generate this new solid model. And here I will show you going back, for example, to Workbench environment. And you can also generate the mesh for this model. So again, this is the idea to generate a very fast solid model, and you can connect again to the assembly, and you can verify very easily if your model is good or not. Talk about stress, displacement, or even for frequency analysis, for example. So here I just will start a new mesh. Here is the independent model. I have the final result of the validation for the assembly. But here I want just to show you that the procedure is easy, even when you are talking about just a single model. But the assembly is the same way. You have just after that to renew some contacts and some parts of your model. So, for example, there's a very nice feature in Workbench. Also try to get the connection of some some faces, which is the virtual topology. So you create virtual topology, and you create virtual cells for everything you can have here. And finally, you can generate the mesh. So here you have a solid model, and the mesh was done. Very easy. You can also control the mesh for some parts of your model, or even you can extend the virtual topology, selecting some faces if you want. For example, here, the mesh, the geometry is not connected. So when you apply the force here, you can also emphasize, for example, virtual cell, for example, for applying the force here. You can have a kind of local virtual topology generation. So, but here I have the final condition for our model. I just open to show you. So after that, when you have the assembly model in SpaceClaim, you can just replace the initial extended design, which was as I showed you before. And now, for example, you can replace it for this new condition. And very easily you can just refresh your contact region. This was already done. And after that you can have the solution of your model. And here you can compare the stress and displacement as you want, for example. So just want to summarize you that for who is working with this methodology of STL file, this new feature of SpaceClaim is pretty nice. So as I told you, there's 4 steps. For example, just separate your model. Second, you can auto-fix, or you can have a better mesh for your model. Third, you can reduce your model. And last part is, for example, you generating the solid model as I showed you before. So just 4 steps and you have a final solid model where you can use this for other situation. So here is, we are reaching the end of this presentation. Today is just 30 minutes. I hope that you like this. And now I want to see if there is some question that I can try to answer you. For a while, Juan asked me something. I will give you some minutes. I will not just open the microphone for everyone because sometimes it's difficult to understand. So now you have an opportunity, 2 or 3 minutes. If you have some questions, just I'm here available for you. Yes, Philip is asking. Philip is just mentioned that you can replace triangles by a plane or other. It could help you a lot on your model. Feel free to send me your STL file to show this. Of course, Philip, thanks for this indication, and also from SpaceClaim, you have after your model, you have the possibility, as it's not parameterized, you can also create more things from this part. So sometimes you can, for example, you can try to put some material on some roads or holes or something like this. So after that, you can work more with your STL model. Anything else? So since there's no more question, if you want to contact me later, we'll send this presentation for you. As we have this your emails. Oh, sorry, there's one more question. Is it possible to get a parametric model with feature lines? Yes, with SpaceClaim you can create something your model after this condition of the solid model, and there are a lot of features you can use it for this. Today we don't have much time for this, but like for example, if you go to design here, you have a lot of drawing situations for lines and circles or other stuff. So you can just create some plan, and you can start to your scratch from this situation. So it's like, for example, you can add features or you can remove features. You can play around a lot of things on your model. So SpaceClaim is basically very nice when you are working with this simulation world and you want to just modify something in your model. You don't want to go back, for example, for SolidWorks or Event or other softwares that you just have to something easier to control and modify on your model, for example. So I will send this presentation for you, and after that, perhaps you can have more information and try to help you to understand a little bit better about how it was the presentation of some features talk about this like I told you before. So thank you everyone once again for joining us. Thank you for your time. I hope that you enjoy and your pleasure to see you again in another WebEx. Thank you. Bye bye.